But John Wheeler was a genius. He came up with all these different concepts and stuff. And two of the interesting things that he was working on specifically with Bryce Dewitt during this period in the 1960s, before physics got corrupted by string theory and sent off a cliff, they were working on resolutions to the paradoxes between quantum mechanics and general relativity and special relativity. Like, how do you merge relativity with quantum mechanics and make the two consistent? And they were struggling to how to do that. And one of the solutions that they came up with was this issue of quantum non-locality. And that's this issue that the substructure of space is on some higher dimensional plane, that space and time are actually like a holographic illusion, and that everything exists all in one hyperplane all at once, and that we just see different things in different specs from different observer viewpoints and stuff. A lot of this was confirmed, years later by like Elaine Aspect and John Bell and others, with some of their experiments. But what that core argument of the quantum non-locality, that explains right there how UFOs are getting here. Because if you can create an Einstein-Rosen bridge between these 2 points in the universe, you can open a wormhole and then just step through. But then how do you do that? How do you do that is another story.
I'm sorry, I'm just dumb, so I don't know what an Einstein-Rosen bridge is.
Yeah, so this Einstein-Rosen bridge, so they kind of came up with this idea of solutions to Einstein's field equations, and a bunch of these, a bunch of people come up with different metrics and different solutions to them. One of the most popular is the Schwarzschild metric, which is what black holes do. That's how that's like the topology and physics of black holes is this Schwarzschild solution. Now these other these Einstein-Rosen solutions are wormhole solutions. So they're solutions to the field equations where you can open up 2 points and connect 2 points of space over
right,
these
like
distances.
folding a piece of paper in half and poking a hole right through it.
Yes, it's all about how you folding the paper and then how you poke the hole. So the opening and the shape of the hole that you poke and all that is super important to doing that. And this bending and folding of space-time. But how do you do that? So the way we can see it being done in physics is that the photons themselves are actually generating and building and producing the space-time. So rather than thinking of relativity as this absolute theory, think of it as a emergent theory that's generated or comes out of quantum mechanics. And one of the guys I like, he does a lot of cool research into this, is Lewis Kaufman. He's a mathematician. He does a lot of knot theory and shows how, he has this whole paper on how relativity can emerge simply from, quantum mechanics and these simple functions. If you just do this expansion and you separate the odd and even terms, you get relativity from that as these two parts. And it's an interesting take on the whole physics of it. Because it's saying that if we, when you shine light, that light is creating an instantaneous, it's building the space-time. The light itself is building the space-time, and it's creating these Einstein-Rosen bridges between every point that these interactions happen. So if you were able to connect these, how do you connect distant points in space-time is you'd have to have a lot of light going between those 2 points that's, going back and forth or focused. And I kind of got in this on Brett's channel a little bit because he was like, making the relativity argument for why aliens can't get here that we've all heard. The speed of light is the speed limit. You can't go faster.
Right.
And that. But
speed of light would take, I think, what was he saying? It would take 100,000 years to get here from somewhere.
But how long does it take for the photon? Because for the photon, it's instantaneous.
Why is that?
The photon does not experience any time at all. In fact, the photon makes the trip, goes backwards, and then to negotiate, and then goes backwards in time, and then figures out which route it's going to take, according to QED, which is quantum electrodynamics, the theory of light, as written out by Richard Feynman, which is super interesting. That's like this pilot. It was the pilot wave theory. It's one interpretation of quantum mechanics. There's two different interpretations. One is this pilot wave interpretation that's Bohmian quantum mechanics, and the other one is Copenhagen interpretation. That's the Schrodinger's cat, where it's both alive and dead. at the same time in the state of superposition before the wave function collapses, rather than it takes the trip, renegotiates, and then figures out which way it's going to go. It's kind of a different approach to the quantum action, the principle of quantum action. But this whole idea is that for the photon and light, it seems, has a lot to do with all this. Because I mentioned in order to create anti-gravity, you need negative mass. So how do you create negative mass?
Right.
Well, they've done it experimentally. Did you know that?
I did not know that.
Yeah, there's an experiment that they did at University of Rochester where they created negative mass in a laboratory, and they did it using something called polariton condensate. Now, what the hell is polariton condensate? Well, it's liquid light. There's another word for it. It's light that's been trapped inside of a material. So when light goes in a material, it produces these quasi particles inside the material by the interaction of the electromagnetic fields to the material. Those are called excitons. And when the excitons are large enough to polarize the actual, physics inside there, the vacuum, you can actually create these polaritons, there's polarons and bipolarons, and these are all quasi particles that you can basically generate in materials. And through these generation of these quasi particles, you can create systems where negative mass can be produced through these polariton condensates, which is liquid light. It's trapped light. So it's fascinating because you see these, UFOs that appear like glowing balls of light, and then they do this warp thingy, and how are they doing that? And is there any, interest, is there any physics behind this? And well, sure enough, light can produce propulsion. There's a number of, I mentioned the radiometer, Crookes radiometer. It's a meter which measures radiation or
the Crookes radiometer.
Yeah, I think that's what it's called.
Mm-hmm.
Yeah. And
this was what you showed me in the Giza power plant book, in Christopher Dunn's book.
No, that was the Crookes tube. That's an electron gun. So okay. Yeah, that was, remember Joe Rogan had Tom DeLonge on the podcast, and he's talking about this, metamaterial that they have that they use to warp space-time. And he's saying, they fire an electron at it and it goes slower, one way than the other. And, Joe Rogan was like, how do you fire an electron at it? And Tom DeLonge's like, I don't know. I'm not a physicist. Mm-hmm. And, the answer is a Crookes tube. That's an electron.
Crookes tube.
That's an electron gun.
It's an electron gun.
Yeah. So that's what you could have used to fire electrons. But this is a little different. So these are photons. These are light particles. And light particles actually, contain mass or they contain momentum, because you can get this thing spinning just by shining light on it. And it's just black squares on one side and white on the other. So what happens on the white side is it's reflecting the light, and on the black side it's absorbing the light.
Right.
So there's an imbalance in the forces from the light, the pressure that the light puts on there. So actually that's what causes the thing to spin or rotate, because how they get the black on one side and the white on the other. So that's the principal concept behind this. So light has momentum, so you can use light to push things. So if you get enough light, you can push heavy this is really light, perfectly balanced thing, and you're using a small amount of light, but it can still push it. But what happens when you get a ton of light and you bounce it around inside this resonant cavity, in this metamaterial that you've created that is made to capture and trap light? It's essentially a piece of glass or a dielectric between two mirrors, so that the mirrors just bounce the light back and forth between the glass, in the middle. So the light goes in, and they're one-way mirrors. So the light goes in and then it gets trapped, and you can bounce it around, and then you can do different things to that light. You can squeeze it, and then you can set up other, xenic surface waves and other types of waves in the structure to produce these different types of condensates. So condensates are condensed matter physics. So it's not like condensed milk where I'm, evaporating all the water out. It's where I'm cooling all the quantum particles so that the statistics that govern them all fall to the same level, so that they start behaving, their quantum mechanical behaviors start becoming more emergent. So you're creating, macroscopic objects that are exhibiting quantum mechanical behaviors. That's how, there might be a window into how to, change physics altogether. And if they're not working on this, then they should be. And I don't think they would have figured this out in the 1950s. I don't think they had the math or the material science back in the 50s. assuming that we captured actual pieces of, UFOs or extraterrestrial technology, we might have, had some of this and maybe back engineered or learned something from studying those pieces. But as far as, us being able to build them and manufacturing them, I don't think we're at that level yet. I think that that's where the problem is right now in the whole industry of being able to do this. That's why I'm not worried about talking about this kind of stuff. I don't think, Russia and China, it would need a very large state apparatus to be able to fund a program and research something like this.